everybody. My name is Amelia Dexter on Amelialand.
And today's Science Day. And we learned about some interesting stuff this week, huh?
Mm-hmm.
We're looking at traits, right? Different traits that animals have and how they get them and how they use them and what they get to adapt to their environment and what gets inherited from their parents. And we did a little experiment related to that today. So, should we set it up?
Let's do it.
All right. So what we were doing is trying to decide how children's traits come down from their parents, right? And how do we do that? Do you remember how it started?
So, we need to cut out a bunch of. I cut out.
We
made some 6x4 rectangles, 6 inches by 4 inches rectangles, and we cut them out, and then I cut out the corners and made an oval on all of them. There were 12.
So we made little children.
Mm-hmm.
And once you had your children, and we also had accessories, right? Hair, lips, noses, eyes, all that kind of stuff.
Mm-hmm.
And you had a table, right? A data table.
A table.
So, go ahead.
And we flipped coins, a lot of flipping coins, and we called out the genes for the mother and the father.
Right. So first we needed to figure out what were dominant and recessive genes for the parents. So we did that by flipping coins. And if it was heads, it was dominant. If it was tails, it was recessive. And we marked it off. And people know this, but the way it works with dominant and recessive genes, as long as there is any dominant trait from the mother or the father, or both, your child's going to have that dominant trait.
Uh-huh.
But if they're both recessive, then you're going to have the recessive trait, which is why recessive traits are more rare than the dominant ones, because you only have 1 in 4 chance really of getting. Right. So we flipped those coins. We found out when we had things to mark down, like if hair was darker or lighter and eye color and stuff, right? And you set up your parents. And then what'd you do?
Then we worked on the first child.
Okay.
We flipped a coin again, and we decided if it was a boy or a girl. The first one turned out to be a girl.
Alright. So then we had 2 coins to flip, right? We each flipped one.
Mm-hmm.
And one represented the mother and one represented the father.
Yeah.
And what did we do based on the results of that?
So, if you got tails, then it would. Now, I never explained this to you before, but D equals dominant and R equals recessive in our chart.
Okay.
So, if you get tails, then it's the first trait. And if you get heads, then it's the second trait.
Alright, so if you had written down based on your coin flipping before that, a certain trait for the mother was dominant and recessive. So you flip a coin twice, you get dominant, you get recessive. If you flip it for your child and the mother's coin comes up heads, you would take the second letter that you picked, right? Mm-hmm. So you take the recessive one. If your coin flip came up tails, you take the first letter from the parent, which would be dominant. And you had a coin for the mother, coin for the father. You flip them, you figure out which one of their traits to take, and you combine them in the child. Right? So we did that for all the children's traits, and then what did we do?
Then we started actually making the children.
So we had all our cutouts, and how did you determine what to put on a child? Like for what hair to put on, and what color hair, what size nose, that kind of thing?
Under dominant and recessive, there were different little printed boxes that told you what you do. If you got recessive, now this is an example for like hair. I remember this one. If you got dominant for hair, then you would get
dark hair.
Yeah, like dark. You get brown hazel hair stuff.
Brown hair, yeah. But recessive was blonde, right?
Yeah, recessive was blonde.
Alright, so if you looked in that child's box, how did you determine which one you should get?
Well, it's the same for the mother and father, actually. So if you had a D in it, then it'd be a dominant trait. But if it was both R's, then it'd be a recessive trait.
So if either parent supplied a D, you're going to do the dominant thing, right?
Mm-hmm.
But if both parents gave you the recessive gene, you're going to do the recessive thing.
Mm-hmm.
So we built 3 children, right?
3.
Yes. Frederella, Fred, and Federico, yes. 3 wonderful children, 2 girls and a boy. And did they have some things that were the same and some things that were different?
Mm-hmm.
Yeah.
I'm so glad I got that name right.
Did you have fun making the children?
Lots of fun.
And did you learn how dominant and recessive genes work?
Yep.
So if you see 2 parents walking down the street with dark brown hair and their little kid is blonde, what might be the answer for that?
Recessive trait.
So they both passed on a recessive trait to their child that happened to be for blonde hair, and their child popped out blonde hair.
But if it wasn't a recessive trait...
Or it could be any number of things, right?
Or it could be that it was the wrong...
It could be anything, yeah.
Yeah, well, it could be anything.
Alright, so, do you have anything else you'd like to add about your very scientific experiment?
No.
Alright, take us out, please.
My name is Amelia Dexter on Amelialand. Telling you, stay tuned.
Signing off.
Signing off.